Today we're going to classify numbers into sets and subsets. So let's first define the numbers that we want to classify. The sets and subsets of numbers that we need to know are the following: natural numbers, whole numbers, integers, rational numbers. Those four you should be fairly familiar with from 5th and 6th grade. The new ones that we're going to talk about are irrational, real, and complex. They kind of fit together like this. Here's kind of a diagram of how they all fit together. Natural numbers are where we start. Whole numbers encompass natural numbers. Integers encompass whole numbers. Rational numbers encompass integers, whole numbers, and natural numbers. And then there's a set inside there that's an irrational numbers. And then real numbers take on all irrational and rational numbers. Then on top of that, we have complex numbers, which are a combination of real numbers and something we call imaginary numbers. So let's define each one of these sets real fast. The first set we need to talk about are the natural numbers, or another name for those are the counting numbers. There are just regular numbers, 1, 2, 3, 4, 5. So it's basically almost like the set of whole numbers that we'll talk about next, minus the 0. Okay, next, whole numbers. Whole numbers are natural numbers, or the counting numbers, plus 0. So we include 0 when we talk about whole numbers. Okay. Then we move to the integers, the set of integers. The integers are the set of whole numbers, 0, 1, 2, 3, 4, 5, and so on, and their opposites. But whole numbers, we need to remember, have no fraction or decimal parts. So in integers, they're going to be the set of whole numbers with no fractions or decimals, and the opposites of those, which are the negative numbers, negative 1, negative 2, negative 3. Because when we talk about opposite, we're talking about the distance away from 0. Positive numbers go to the right a certain distance. Negative numbers go to the left the same distance away from 0. That's what it means to be opposite. Rational numbers. A rational number is any number that can be expressed as the quotient or fraction p over q of two integers, with the denominator q not equal to 0. So basically, a rational number is any number that can be written as a fraction. So when we looked at our integers here, we've got all these 0, 1, 2, 3, 4, 5. Rational numbers are all the numbers in between also, like 1.5 or 1.5, and all of those. Any number that can be written as a fraction. Here's some examples of those. 1/2 is a rational number. 1 divided by 2, it makes a fraction. 0.75 makes 3/4. 1 is also a rational number. Any whole number is a rational number because it can be turned into a fraction by putting 1 underneath it. Negative numbers are also rational numbers as long as you can write them as a fraction. Right? So there's our rationals. Then we go to the set of irrational numbers. Irrational numbers are a real number, we'll define real in just a second, a real number that cannot be written as a simple fraction. Okay, the decimal will go on forever without repeating or terminating. Okay, so irrational numbers are numbers that can't be written as a fraction. Okay, when you divide them out or you do the math on them, they will give you a decimal, but it will not repeat and it will not terminate. It will stop. One of the most famous irrational numbers that we have is pi. Another one is the square root of 2. Okay, so those are all what we call irrational numbers because they will give you a decimal that will not repeat and will not terminate. Then we have the set of real numbers. Real numbers are exactly what it seems like. These are all the numbers that you basically know. It says it's the type of number we normally use, such as 1, 15.82, negative 0.1, 3/4, etc. Positive numbers or negative numbers, large, small, whole, or decimal numbers. They're all real numbers. So basically, real numbers are any number that can be put on a number line. Okay, they are called real numbers because they're not imaginary numbers. And yes, there is such a thing as an imaginary number. So let's look at those imaginary numbers. This is one that we did not have on the list, but it is something that we need to know about before we can talk about complex numbers. Imaginary numbers are numbers that when squared gives a negative result. Normally when you square something, you get a positive result. If you square a real number, you always get positive or 0 result. For example, 2 times 2 or 2 squared is 4. Negative 2 times negative 2 or negative 2 squared is also 4. Okay, so imaginary numbers, we won't really deal with them in 7th grade, but we will deal with them whenever we get into Algebra 1. Okay? Then we have complex numbers. Complex number, they are a combination of real numbers and imaginary numbers in the form of a plus bi, where a and b are both real numbers, and I is the first imaginary unit, or the square root of -1. Okay? As you saw in this previous slide, if we take the square root of -1, you get the value of I, okay, which is what we use to represent an imaginary number. So let's see if we can kind of place a few of these numbers here where they're supposed to be. Like take, for example, this 5. Okay, well, this 5 is a natural number, okay, because it's a counting number. But it could also be a whole number. It could be an integer. It could be a rational number because we can write it as a fraction. It can be a real number, but it won't be irrational or complex. So 5 actually belongs to 5 different number sets. But this -12 right here, it's not going to be a natural number because it's not one of our counting numbers. It's not going to be a whole number because it's negative, but it will be an integer because whole numbers are our counting numbers plus 0, and the integers are all the whole numbers plus the opposites of those, which -12 would be. -12 would also be irrational, and it would also be real. Now this pi, we just talked about pi being our most famous irrational number. So it's an irrational, but pi also is a real number because you can place it on a number line. It's just a little over 3. Okay? 6.4, well, it's not going to be natural because it's got a decimal. It's not going to be whole because it's got a decimal. It's not going to be an integer because it's got a decimal, but I can write it as a fraction, so it's going to be a rational number, and it would also be a real number. Okay? This 3 plus I, well, if it's got the real number and an imaginary number, that's going to be what we call a complex number. Okay? So those are some of the numbers that we kind of place on there. And so numbers can actually fit into more than one category. And that's what we need to understand about sets and subsets of numbers. Here's kind of another example of all the different type numbers that you can have within your number systems. So I hope that helps make it a little bit more clear as to where numbers fit into the number systems.